Okay, this is section 3.5. All right, find the domain of this graph. By the way, the graph is the dark line here. These dashed lines right here and right here are invisible. They're meant to be invisible. Those dashed lines are called asymptotes. And when the line is horizontal like it is, it's called a horizontal asymptote. And this line is vertical, so it's called a vertical asymptote. Okay, asymptotes are invisible lines your graph cannot cross. So asymptotes are these invisible lines right here. You see the graph cannot cross. Now, sometimes horizontal asymptotes, you can cross those, but I mean, you see them sometimes. But normally asymptotes are invisible lines your graph cannot cross. Here's our graph. This black line is our graph, and this black line, if we went on forever, is our graph. Do you see? It gets really close to the red line, but it never crosses it. Same way with this asymptote. It gets really close to this graph. The black lines are the graph. That's the graph. And that's the graph. So the graph gets really close to the asymptotes, but they never cross them. They never cross them, okay? So it says find the domain and range of this function. Well, if you look, the domain is what can x equal. If you look here at x negative 8, this graph right here is x negative 8. The part of the graph is x negative 10. You know, there's a y value, but I'm just looking at the domain right now. This this value right here is x equals 2. So the domain is x can equal everything, except there's one number x cannot equal. Do you see? These are all x values, x values, x values. The only thing x cannot equal is -4. X cannot equal -4. Look at this graph. I could put a dot at any x value, x negative 2, x negative 1, x 0, x1, x2, x3, x4, x5, x6, x7, x8, and so on. X7 is way down here, x negative 6, x negative 5, or I'm sorry, -5, -6, -7, -8, -9. The only x you can't have is -4. X cannot equal -4 because that's an asymptote. So the graph cannot cross or touch -4. It equals everything else. So one way of writing the domain is from -infinity to -4. And then it's the union of -4 to infinity. You see, this graph goes all the way to -infinity on the x-axis. It stops at -4. It doesn't cross it. Then on the other side of -4, do you see right here, way up there, on the other side of -4, the graph starts up again and it goes all the way to infinity. So this is how you write the domain in interval notation. X equals everything except -4. It stops at -4 and then jumps over it and starts up again on the other side of -4. Now the range is Similar, range is what can y equal, and I'm going to do range in dark blue. If you look, this graph goes way down here. So the lowest part of the graph is negative infinity. It comes all the way up. Uh-oh. I don't know what I just did there. So the graph comes all the way up and it stops right here at -3. You see, it can't cross -3. But then on the other side of -3, it starts going all the way up to infinity. And it's a union of that. So in other words, you can say range is y. Y cannot equal -3. It equals everything else. And that's the union symbol that you put in there when you have two separate intervals. Do you see y goes all the way down here, negative infinity, comes up, and it gets really close to this y -3, but then it jumps on the other side of -3 and goes all the way up to infinity. So because of the horizontal asymptote, y cannot equal -3. That is where the horizontal asymptote is. I do want to talk about questions 3 and 4 now. If we were going to write this function, write this equation, you can write it y equals, or you can write it f of x equals. The top part of the function are the x-intercepts. The bottom part of the function are the vertical asymptotes. So we have one vertical, remember that's the vertical, it's a vertical line. One vertical asymptote at -4. And we put a +4 in here because if you say x plus 4 equals 0, take the 4 to the other side, x equals -4. That's your vertical asymptote. You see at -4, the vertical asymptote. So we put all vertical asymptotes on the bottom. That means the vertical asymptote is at x equals -4. Then the x-intercept is where does your graph cross the x-axis? Let's say it crosses right there at -1. We put a +1, the x-intercept, up here because x plus 1 equals 0. When you take the 1 to the other side, you get x equals -1 for your intercept, your x-intercept. So the top are the x-intercepts, the bottom are the vertical asymptotes. And you always have the vertical asymptote start with x equals. So this is how you would write this equation, and we're using this for number 3 when we get to that here in a little bit. Okay, I just wanted to do a quick introduction to that. Let's try question 2. Find the horizontal, find the horizontal and vertical asymptotes. So there's your horizontal asymptote. Horizontal asymptote always start with y equals. The horizontal asymptote is at y equals 2. You see the horizontal line goes right through 2. Then it says now find the vertical asymptotes. Vertical asymptotes always start with x equals. And we have 2 vertical asymptotes. Two vertical asymptotes are invisible lines your graph cannot cross. One's at x equals 4. The other one is at x equals -4. Do you see these vertical lines go through x equals 4 and x equals -4? So that's the horizontal and the vertical asymptotes. So if I were going to write this equation, the equation is you can write it as a function or y. Remember, the top part is the X-intercepts. The bottom part are the vertical asymptotes. Vertical asymptotes are at -4, so I'm putting a +4 in the bottom, and at +4, so I'm putting a -4 at the bottom. You see, you put the opposite signs when in there. The X-intercepts, there's one, the graph crosses right here at x equals -5. So I put a +5 in there for the intercept. The other one crosses at 5. The graph crosses the x-axis. X-intercept is where the graph crosses the x-axis at 5. So I put x -5 in there. And this is how you would start off by writing an equation. And normally you also have a multiplier. We call it a in front here. And we'll look at the a's when we do question 3. So the domain for this function, the domain in range, if you look, the only thing x cannot equal are my vertical asymptotes. Do you see right here? So x cannot equal -4 and x cannot equal 4 because the graph gets really close, but it doesn't cross it. Same way here, gets really close to 4, but it doesn't cross it. These are my my vertical asymptotes. So the domain for this problem is everything except -4 and 4. So if you start at the far left, we go from -infinity to -4. Then we jump over the other side of -4. If you look, the graph goes to +4. It jumps over, and then it starts up again at 4 and goes to infinity. So this is how you would write the domain. I mean, you can also write the domain like this. X cannot equal these two, but in interval notation, this is how you would write it. They both mean the same thing. X cannot equal -4 and x cannot equal 4. Range, the range is everything except the horizontal asymptote right here at 2. You see all the way down here, -infinity comes up, and then it's +2. Range is x cannot equal +2. Oh, by the way, yeah, range is always y equals, sorry. Y cannot equal 2. The range y cannot equal 2. We start down at the lower end of infinity. The graph comes up like it's getting ready to cross 2, but it never crosses because it's a horizontal asymptote. Then it starts up again, and it doesn't start up again until 3. So you can say -infinity to 2, but then this graph, there's no graph right here. The graph starts back up at 3. And it looks like it equals 3. It's touching 3 like a parabola, and then it goes all the way up on the y-axis to infinity. So this is how you would write the range. The range would be like this, from -infinity to 2, and then it gets a little gap here. There's no, between 2 and 3, there's nothing. So we start up again at 3 and go all the way to infinity. All right, so let's look at question 3. Write the equation. So we're going to write the equation, y equals, and don't forget, the top of the equation is the x-intercepts. The bottom of the equation are the vertical asymptotes. So the x-intercepts are at 3 and 4. So you just put 3 and 4 in here. When it's a +3 and a +4, you have to put negative numbers, right? X -3 equals 0. To get the 3 to the other side, you add 3, and you get x equals 3. That's why you always do the opposite sign when you put it into the actual equation. Okay, the vertical asymptotes are at x equals 1. So I'm putting x 1, so a minus 1. It's a positive 1, so we put a minus 1. Now, there's a couple of things you need to know. Look at the top. The top, if I multiply this, I get x squared. Do you see? I mean, the highest power is an x squared. If I multiply the top out, the highest power is an x squared. Now, if you FOILed this, x times x is x squared. There's 3 scenarios that I'm going to talk about. If you have the same powers, if you have an equation and you have the same powers, the horizontal asymptote are the numbers in front. Horizontal asymptote always starts with y equals, and it's 2/3 if the powers are the same. Okay, if the top power is more than the bottom power, then there's no horizontal asymptote. And finally, if the top power is less, top is more, the top power is more, powers on this one are the same, and here the top power is less, then the horizontal asymptote is y equals 0. If the top power is less than the bottom power, then the horizontal asymptote is y equals 0. So it says our horizontal asymptote in this problem is 1. So if we have a 1, that means the powers have to be the same. Do you see? If this one there's no horizontal asymptote, this one, the y equals 0, if we have a horizontal asymptote, the powers have to be the same. And if the powers are the same, we only have one x or vertical asymptote, like they said. We only have one vertical asymptote. But the top, if you multiply it, has an x squared. The bottom only has an x. So I have to put a 1 and a 1 in front, because our horizontal asymptote is, it says our horizontal asymptote right here. I'm sorry, I'm making a big mess, is 1. So I have to have the same power. The top power is 2, so the bottom power has to be 2. So I just put a square here. Now I have x squared. And when I multiply these two, I get x squared. So if you have a horizontal asymptote that's a number other than 0, the powers on top, when you multiply it, have the highest power on top has to be the same as the highest power on the bottom, and then you put numbers in front. That's what the A is. Do you see? The A in this case would have been 2/3. Here the A is 1. The A is 1 because the horizontal asymptote is 1. And that's it. This would be my equation, and I can erase the 1s. When you have a 1 in front of the equation, you're done.
All right, now I'm recording. It might be too late. So there's 3 scenarios. If the power are the same on the largest power for the variable, the x, is the same, you use the numbers in front of those powers as your horizontal asymptote. If the power on the bottom is larger, then your horizontal asymptote is y equals 0. If the power is larger on top, then there's no horizontal asymptote.
Are you still sharing your screen? I can't see it anymore.
Well, I thought I was. Yeah. Anybody else?
Yeah, I'm able to see your screen.
Okay. Why can't you see it?
I don't know. I lost service on my laptop, so I'm using my phone. That could be why.
Oh. Well, I think cell phones are compatible with Zoom.
Yeah, they are. I just can't see your screen. I'm going to try to get my laptop together, but I can always watch the recording as well.
Okay, yeah, I just started recording. We got to remember to start recording at the beginning. So I'm going to go ahead and erase all of this. Now that, I mean, I'm going to erase all this for room, but we just have to remember those 3 rules. Okay, so once again, we're going to write a rational function. The top deals with the X-intercepts. The bottom deals with the Y-intercepts. The bottom doesn't deal with the Y-intercepts. The bottom deals with the asymptotes. I'm going to erase that. The bottom deals with the vertical asymptotes. So the X-intercepts are 3 and 4. So in order for us to write the X-intercepts 3 and 4, we just have to write it like this. Can somebody tell me why I write it in there X minus 3 when we're dealing with a positive 3? Because in order for X to be 3, remember, you have to have it set up X minus 3 equals 0. It's this equals 0 equals the function. So to get the 3 to the other side, you add 3. So the intercept is X equals 3. So that's why you have to put the opposite signs when you write the actual function. So that's the top of our rational function, just using the intercepts. Now, the bottom of our rational function is the asymptote. We have a vertical asymptote at X equals 1. And once again, at X equals 1, X minus 1, you have to write it X minus 1. To get the 1 to the other side, you have to add 1, X equals 1. So it's written like this. And we have a horizontal asymptote at, give me 1 second. There we go. All right, so we had 3 and 4 as our X-intercepts. That's the top. A vertical asymptote of positive 1. I want to look, oh, there's one more thing. Our horizontal asymptote equals 1. When we look at our rules, the only way to get a horizontal asymptote for y equals 1, if the top power and the bottom power were the same, if the top and bottom power were the same, that means you have to use the numbers in front. Anybody know what the numbers in front of these x squares are?
1.
Yeah, 1 over 1, which equals 1. Do you see? That's how, look at the top power. If we multiply this together, we get x times x, we get an x square. On the bottom, we only have an x. But in order to get a 1 for a horizontal asymptote, these powers have to be the same. So you have to understand that we have to square this bottom so the powers are the same. So we just put a square there because we know the horizontal asymptote is 1. The only way to use the horizontal asymptote, the 1 and the 1 here, is if the top has a power of x squared and the bottom has a power of x squared. So we had to put a square in this problem. We had to actually put a square into this problem. So now I'm going to rewrite it once again. And there's one more thing we have to do. We have the x minus 3 here. We have the x minus 4. We have the x minus 1 squared here. So the last thing we have to do is this y-intercept part. The y-intercept is 12. So y equals 12. You know, y-intercept, x is 0, y is 12. Don't forget on y-intercepts. So if I change all the x's to 0, 0 minus 3, 0 minus 4, and 0 minus 1 squared, it should equal the y, right? F of x is the same thing as y. It should equal the y, and y equals 12. It should equal 12. Well, 0 minus 3 on top is negative 3. 0 minus 4 is negative 4. On the bottom, I got negative 1 squared left over. Negative 3 times negative 4 is a positive 12. Negative 1 squared, negative 1 times negative 1 is a positive 1. Do you see how it does equal 12? So that means there's no numbers that we have to add to this or change. So, so our function here, since we plug 0 in and we get 12, this is our final answer. That is our answer. I mean, I know the first one's always a little rough to look at and do, but the rest of them are going to be worked out the same way in this situation. So let's just try another one, and I think that will help. I know there's got to be some questions, but we'll see if we can do this problem and it clears up all questions, because it'll be less messy. Hopefully less busy. Write the equation for the rational function. So I know I'm going to write a function, and the top are the x-intercepts. The bottom is the vertical asymptotes. So the x-intercepts are 1 and negative 4. So on top, 1 is minus 1. Now a negative 4 is a plus 4. You have to change the sign, right? To get it to the other side, you subtract 4. So that's the top. That's my x-intercepts. Vertical asymptote is at x equals 0, x minus 0, and minus 5. These are the vertical asymptotes. X minus 5, so we put plus 5. By the way, I just want to make sure everybody understands the vertical asymptote at 0, x minus 0 is just like saying x, right? You see x minus 0 is x. So that's a 0, and this is a negative 5 vertical asymptote. The horizontal asymptote, once again, is y equals 1. When you, that means the powers have to be the same. When you have y equals a number, then the powers have to be the same. And on the top, I have x squared, and on the bottom, I have x squared. So we don't have to add any x's or anything. So we have x squared on the top and the bottom. I think that's it. Y-intercept, it doesn't say there's any y-intercepts. Can somebody tell me why there's no y-intercept? I could look at this equation and tell you that there are no y-intercepts. Can somebody tell me why? Okay, well, remember y-intercepts are when x equals 0, and then we find out what the y-intercept is. Here it says there's no y-intercept. Look what happens if I put 0 into this function. If I put 0 here, I get -1. If I put 0 here, I get +4. If I put 0 here, I get 5. But if I put 0 here, I get 0. And 0 times anything is 0. We cannot have 0 on the bottom. You can't divide by 0. So that's why we can't get an answer for the y-intercept, because we have 0 on the bottom when we plug 0 into x. So there is no y-intercept. We are done. I mean, this is our equation, x minus 1, x plus 4, x times x plus 5. Y equals, or f of x equals, however you want to write it. That's our function. We write the top using the x-intercepts, the bottom with the vertical asymptotes. And we have to realize anytime y equals 1, the powers on the top and bottom will be the same. And that's it. So that's not too bad. Just as long as you remember this part here, the top is the x-intercepts and the bottom is the vertical asymptotes. All right, question 5. We need to sketch the graph. So we're just doing backward what we previously did. Remember, the top is the x-intercepts. The bottom is the vertical asymptotes. Now look at the bottom again. Oh, it just says sketch the graph. But look at the top. The top has an x on it. The bottom has 2 x's. X times x is x squared. So if you look at our horizontal asymptotes, we're not looking at the vertical. I'm talking about the horizontal asymptotes. If the bottom power is larger than the top power, then the horizontal asymptote is x equals 0. Horizontal asymptote is x equals 0. It's not x equals 0. Horizontal is y equals. So we said if the bottom power was larger than the top, then the horizontal asymptote is y equals 0. The x-intercept is the top. 4x equals 0. You just set it equal to 0. Get the 4 to the other side by dividing by 4. 0 divided by 4 is 0. So my x-intercept is 0. The graph goes through x0. There's a point right there. The vertical asymptotes. One vertical asymptote is at -1. You see x plus 1 equals 0. Take the 1 to the other side. X equals -1. So at -1, there is a vertical asymptote, an invisible line your graph will not be able to cross. There's also another vertical asymptote, 2x plus 9 equals 0. First, you take the 9 to the other side, and then you divide by 2. We're solving. And x equals -9 over 2. -9 over 2 is the same thing as saying -4.5, 4.5, which is right here. There is a vertical asymptote that goes through there. This is -9 over 2, -4.5. Okay, so, and we have that horizontal asymptote that goes through here. By the way, there's something weird about horizontal asymptotes where it's equal to 0. Your graph sometimes can cross it, so don't be alarmed if your graph crosses a horizontal asymptote that's y equals 0. That's the only exception. These other asymptotes, vertical asymptotes, your graph can never cross them. It says graph these now. So, I mean, if I was doing a multiple choice test, I'd look to see that I have 2 vertical asymptotes, one at -4.5 and one at -1. And then we want to look at the rest of the graph. I would plug some test points in. Let's plug 6 into this, x6 into this equation. 4 times x, 2 times x plus 9 over x plus 1. And everywhere there's an x, we're going to plug something in. Let's, like I said, let's plug a 6 in there. And so the top is 24. 2 times 6 is 12, plus 9 is 21. And so we get 21 times 7 is 147. So at 6, when x equals 6, 24 divided by 147, I get 0.16. So you at 6, I get 0.16, which is the dot right here. So what happens is, and by the way, I mean, my graph is here, this one was 0, and that's 0.16. That means it's just going up slowly. I can't cross this line. I know I cannot cross this line, but if I get really close to it, if I put -1/2 into the x spot, watch what happens when I put 1/2 in there, -1/2, -0.5, -0.5, -0.5. On the top, I get 4 times -0.5 is -2. And on the bottom, I get -10 plus 1, which is a -1. And then I get a -0.5. 2 divided by 0.5 is we end up with a -4. So at -1/2, we go down to -4. Do you see this graph goes down? I know it doesn't cross. It gets really close to that line, it doesn't cross. So this graph looks like this, and then it'll start going up. And in reality, I think that's all you have to graph to pick the correct answer. Now, on the homework, they're going to make you, I think on the homework, they're going to make you graph this whole thing. What you have to do is put a whole bunch of test points in there, like -3. So you're going to need 2 test points in this range, like maybe -4 and -2. So you know where this graph is. And I don't want to spend hours on this, but let me work out one at least, I guess. So we're going to plug -2 into the original equation. -2, -2, -2, -2. Let me erase this. I could have just put it there at the top. -2 times 8 is -2 times 4 is -8. On the bottom, -2 or 2 times -2 is -4, plus 9 is a +5. -2 plus 1 is -1. So -8 divided by 5 is like a -1.3, something like that. -8 divided by 5, -1.6. So at 2, we go to -1.6 right there. And let's try 4, -4. Let's try -4 now. -4 times 4 is -16. 2 times -4 is -8. Plus 9 is 1. -4 plus 3 is a -3. So I get a -16 divided by -3. And is that right? I guess it is. -16 divided by -3, -16 divided by -3, I get a -5.3. So at -4, we get 5.3. Here at -4, we get 5.3. 5.3 is about right here. So if you look at this graph here, this graph is getting really close to that line, and then it curves down this way. But it doesn't cross that intercept. It doesn't cross that asymptote. I know it's kind of messy. So we can draw it like this. It gets really close to the asymptote, and then at some point it curves up and gets really close to that asymptote. And then on the other side, I'd be willing to bet it's going to be very similar to the other one. It'll look kind of like that, and we'll just verify it by putting one number in there, -8. So you're putting all these numbers into the original equation. This was the original equation, right here. If I put -8 in there, put -8 here, put -8 here, -8 times 4 is -32. 2 times -8 is -16 plus 9 is -7. And -8 plus 1 is -7. So I get -32 divided by a +49. So I get a little bit less than 1, at -8. I get a little bit less than -1. So it'll be about right here. And if you look, I think, so my graph was a little, it should be. It looks like my graph more than likely would be like this, but then it's going to get closer and closer to that asymptote. All right, so that's what the graph looked like. Here, you just have to put a lot of test points. You got to, it might take 2 or 3 different test points for each area to be able to draw that picture. That's why I said these are not easy, just because you have to plug in several test points. All right, any questions? I know this is tough, especially when it's online like this. Let's see what else we have. So let's sketch this graph. How many do we have all together? 6, 7, 8. So that's the last one, number 8. So this one. In order to find the X-intercepts and the asymptotes, here, previously everything was factored. So we have to factor the top and the bottom. Well, luckily, there's nothing in front of the x square. So that means we just take all the factors of 7. 1 times 7, that's it. A +7 and a -1 give me a +6. So this factors to x minus 1 and x plus 7, the top. I should have left it as black. On the bottom, 20 factors to 1 times 20, 2 times 10, 4 times 5. And if you look, we need to get a -1, and we can get it with a +4 and a -5. So the bottom factors to a +4 and a -5. So that's what we have for our, so we factored it all. If you look, the top and bottoms are the same. So we have a horizontal asymptote at y = 0. There is a horizontal asymptote then at y = 0. I might as well draw that. By the way, don't forget, sometimes you can cross horizontal asymptotes. We also have 2 asymptotes. The bottoms are the asymptotes. Remember, one at -4 and one at +5. So there's an asymptote that goes through 5. and there's an asymptote that goes through -4. So, I mean, if you look, that this isn't really important just to be able to draw those asymptotes. Just to be able to draw those asymptotes, because you can usually tell which graph it is from the asymptotes. Now we just need a whole bunch of test points to figure out where this graph is. I mean, it doesn't tell us anything. Oh, it does tell us something. The Y-intercept. We know where the Y-intercept is wherever x equals 0. So in the original problem, here's the original problem, factored, by the way. -1 and 7. If I put 0, right, X-intercept, if I put x equals 0, everywhere there's an x, I put a 0, I get -1 times +7, that's a -7. And on the bottom, I get 4 times a -5 is a -20. So my X-intercept is 7/20. Negative divided by negative is a positive. 7 divided by 20 is 0.35. Do you see? There's an X. Our graph crosses right here at 0.35. That's the Y-intercept. When x is 0, my Y-intercept is right there. Okay, so now we need some test points. Oh, no.
I have a question real quick.
Sure.
About the asymptotes.
Yes.
So let me see. It's -4?
Yes.
Not -5?
Right. Because remember, the asymptotes, you have to set x plus 4 equal to 0. So to find out what x equals, you take the opposite sign to the other side. X equals -4. Do you see? That's the actual, when you write it like this, x equals -4 to get the 4 to the other side. So those asymptotes are always going to be the opposite sign of the factored form.
Okay, got it. Thank you.
Okay, sure.
Mr. Troutman,
Yes.
how'd you get the asymptote through the x-axis, the dashes through the x-axis?
Oh, you know what? You're absolutely right. That asymptote doesn't exist.
Oh, okay.
Can you tell me what the asymptote is? The horizontal asymptote? Now that you asked the question.
Vertical, horizontal. No.
When the powers are the same, look, the x squares, it's always the number in front of those x squares. And there's a 1. Do you see? So
okay.
It's y equals 1, not y equals 0. The horizontal asymptote is y equals 1. And we put a dot right here. See, our graph is not going to cross this. I guarantee this is what our graph is going to look like. It's going to look similar to this because it can't go up here. You know, there's an asymptote there that won't let us cross it, hopefully. So we'll do a test point. We'll put -3 in the test point and maybe +4. So if I go back here and put -3 in there, -3, -3, -3, -3, -3 minus 1 is a -4. And -3 plus 7 is a +4. And -3 plus 4 is 1. And -3 minus 5 is -8. So if you look, -4 times 4 is a -8 on top. And then on the bottom, 1 times -8 is -8. So at 4, we get 1. So this does go down somehow, just not as, it just goes around more. So let me try one at 4, at x equals 4. So we're just going to have to plug in a lot of test points for these things.
So for our test, are we going to have to plug in a lot of test points as well?
You're gonna, I mean, hopefully, if you see these asymptotes and none of the other questions of the asymptotes, you could stop. Yes, you have to match the correct picture with the correct graph. You know, when it says sketch this graph, they'll give you 4 pictures of graphs. So as soon as you can graph, I mean, look at where, all you have to do is, okay, look at the ones that have the same asymptotes that you do. And then let's say there was one graph that had something up here and one graph that had something down here. So do a test point. If your test point ends up being down here, then you pick that graph. So, I mean, you don't have to make your graph look exactly like the whole thing, but you do have to be able to pick out the correct graph.
Okay.
So, I mean, let's look at a test point 8, because the graph could be up here or the graph could be down here. Do you see? It could be either way. So if we put 8 into this problem, if I put 8 into this problem, we'll know which side the graph is on, or, you know, where the graph is on. So if I put 8 in there, 8 minus 1 is 7, 8 plus 7 is 15, 8 plus 4 is 12, 8 minus 5 is 3, 7 times 15 is 105, divided by 36. That's somewhere around 3. It's a little bit more than 3. But do you see the graph would be up here then? The graph would be up here, because at 8, the graph is at 3. 1, 2, 3. You see the graph crosses 3 at that point. And then you would do the same thing over here. Put -8 in there and it'll tell you where this graph is. By the way, that's not where the graph is. So if I put -8 in here instead of 8, -8 minus 1 is -9, -8 plus 7 is -1, -8 plus 4 is -4, and -8 minus 5 is -13. So I get 9 over positive 52. 9 over positive 52 is very small. It's less than a half, so it'd be right here. So it looks like this graph, well, at -8, it's right there. I think I would have to put a -5 in there to see it. By the way, I'm gonna put this in my calculator really quick, and so I can draw exactly what it looks like for you without doing a million test points and taking all day. X squared plus 6x. The test is gonna be easier than the homework. I promise you the homework will be tough. It's a tough section. But the test is not as tough because you just have to pick the correct. You can eliminate questions, problems, x squared. You can eliminate answers by looking at it. So when I graph this, I need to change it to -10, -10 graph. And sure enough, oh, look, wow, I was way off. We didn't do enough test points. On this one, it actually, we didn't do a test point for this side. It actually goes up like that. Like I said, sometimes it will graph, it will go through a horizontal asymptote. So if I would have did a -3 test point, if I would have did a -3 test point, I would have saw the graph was way up there. And this one is exactly as we predicted. It looks like this. The graph can't cross. It can't cross. If we have a point here, it can't cross there, it can't cross here. So it has to stay within and get really close to those lines. So with this one, we predicted, we said, yeah, there's a graph and it has to stay within those boundaries. But this one, we didn't do a test point on this side, that the graph actually goes up there. So this is what the graph actually looks like. So it does take a few test points to be able to eliminate the other problems. I think it's on the test, it's going to be easier than the homework. On the homework, you're going to have to try to be able to draw these, and good luck with that. I'm not exactly sure how they're going to have you do that. I'll look at the homework myself when we're done here. But it's the homework is tough. Just go through this process when you're doing the homework, and then the test will be much easier because you just have to pick the correct answer. You have to just do test points until you can see the correct answer. So just like the previous problem, we want to write the rational function. Not the previous one, a couple of before that. Here's our function. And don't forget the top is the X-intercepts. Last time they gave it to us. This time we have to do the graph. Vertical asymptotes, the bottom. And can anybody tell me what the vertical asymptote is? Where on this graph is the vertical asymptote? It's a vertical line.
Is it -3?
Yes, that's the vertical asymptote. Vertical asymptote is x equals -3. In order to put it down here, you have to put +3, right? You have to put the opposite sign when you put it in there. To get it to the other side, you have to add 3 to both sides. The X-intercepts, where the graph crosses the x-axis, are right here. The X-intercepts are at x equals 0 and x equals -6. So one of them, x equals -6, you put a +6 in there. X equals 0 is just x. So it's +0, so you're not taking anything to the other side. Now, if you look at the top, and do you see how there's a horizontal asymptote? There's a horizontal asymptote at 1, at y equals 1. That means the top power is 2, has to match the bottom power. Horizontal asymptote where y equals 2, the top power and the bottom power have to match. Up here, I got x squared, but on the bottom, I only have x. So you have to make an x squared on the bottom. And the only way to do that is saying, oh, that's squared. And there's just one more thing we have to do. Oh, no. No, I don't think we have to do it. Oh, the y. I mean, we're done. By the way, this is the answer. We're actually done. That's all you had to do. Once again, the x-intercepts are the top, the y-intercepts are the bottom. X-intercepts are where the graph crosses the x-axis. The bottom is the vertical asymptotes. And I was just looking at the y-intercept. The y-intercept is 0, wherever x is 0. And sure enough, if I put 0 here, I get 9 on the bottom. If I put 0 on top, I get 0 times 6, which is 0. 0 divided by 9 is 0. So it holds true also for the y-intercept. Changing x to 0, nothing changes. So yes, that is my answer. X times x plus 6 over x plus 3 squared. You just had to remember to square the bottom because the powers on top and the powers on the bottom have to be the same when you have a horizontal asymptote of 1. So that wasn't too bad. I mean, they for a question like this on the test, they give you this graph. They give you this graph, and they would say, hey, which one of these equations And you had to recognize, okay, there's an X-intercepts, and there is the asymptote. It has a square because there's a horizontal asymptote going through y equals 1. Not too bad. And we're going to try the same thing with this one. When we do this, once again, X-intercepts are the top, and the vertical asymptotes are the bottom. Where does the graph cross the x-axis? It crosses right here. So my x-intercept is x. My x-intercept is at x equals -1. That's the x-intercept. To write it, you have to put a +1, opposite sign. Do you see there's no horizontal asymptote going through 1? That means the top power and the bottom power isn't the same. The horizontal asymptote is actually going through 0. That means the top power is smaller than the bottom power. My vertical asymptotes are here at y, or at x equals -5. Does anybody see the other vertical asymptote? There's actually one more. Here's one, y equals -5. Does anybody see the other one? You don't see the dotted line that the graph cannot cross? There's one right here. You can't see the dotted line because there's a solid line underneath it. Do you see how the graph doesn't cross at this point 0? It gets really close to it on both sides. It gets really close to it, but it doesn't cross it. So there is an asymptote there at y, I keep on putting y there, but asymptotes are x, at x equals 0. So we have one x equals 0 and the other one x equals -5, which we put a +5. And that's our graph. That's our equation. That's it. The top is the x-intercepts, the bottom are the vertical asymptotes. Not too bad.
Mr. Chopman, can you go over the vertical asymptote one more time? I didn't really catch what you were saying. It didn't really click for me.
Oh, okay, sure. Hang on. So it looks like, in this problem, it looks like there's one vertical asymptote, right? Through x equals -5. Do you see? We know it's a vertical asymptote because we see the dotted line. But even if the dotted line wasn't there, I'd know it was a vertical asymptote. By the way, a vertical asymptote is an invisible line your graph cannot cross. So if we did it on our graphing calculator, you couldn't see the line because a vertical asymptote is invisible. But we indicate it with a dot here, and it's crossing right here at -5. So that's 1, right? So
right.
There's another one. Look at our graph. You have to actually watch our graph. Do you see how my graph, it's not crossing this? There's actually a vertical asymptote. You can't see it, but it's going right through here. There's a vertical asymptote. Because it's a solid line, you don't see the dotted line.
Right.
So there is another vertical one at -5, and there's one at 0. So in our equation, we have to put one at -5, which we put a +5. The one at 0, we just write an x. You know, you can put x + 0, but x + 0 is the same thing as just x. And on the top, we already said on the top, the y-intercept was -1, so we put a +1 on top. And that's our equation.
Thank you.
Sure thing. And that is the end of that section. So on Tuesday, when we come back, we'll do a test review, and then we'll take the test sometime. On Thursday, when we come to class next week, I'm going to cover the next section. So we won't take the test on Thursday in class. We'll take it at home. I'll give you like 5 days to take it. Wednesday, Thursday, Friday, Saturday, Sunday of next week. You can take it at any time. You can use your notes, and that'll be it. Any other questions before we end?
No, sir. Thank you.
Okay, I'll see everybody